Everyone, so welcome to another video lesson on grade 7 mathematics quarter 4 module 3. So let's start. So our topic for today is on graphical presentation of data. This lesson allows you to explore different ways of presenting data using graph or charts such as pie chart, bar graph, line graph, histogram, and ogive. This will help you realize when to use such kind of graph and what information each of these types can provide. So we have the following lesson objectives. So the first one, identify the different graph in presenting data. Describe the different graph in using frequency distribution and illustrate the distinct graph in presenting data. So here, let's start. Presenting data. We often experience that it is not easy to digest information presented in a paragraph or paragraph of facts or in tabular form. There are several ways in which you can present information in the form which is easier to analyze and interpret. So the first one, we have pie chart. A pie chart or pie graph is presented by a circle divided into slices or sectors of various sizes. It shows that the relationship among parts as well as the relationship of a part to a whole. So the data are presented in percentage form and represented in the pie chart by an equivalent fractional part or sector of a whole. So example, here is an example of a pie chart. So the table below shows how Tyra spends each part of her budget. So let us construct a graph to visually display her data. So here is the table, Tyra's budget, item, and then percentage. So for the first one, we have the first item, food, 40%, clothing, 20%, utilities, 25%, entertainment, 10%, and savings, 5%. So here is the her budget in a pie chart. So for food, we have the orange one, 40%, clothing, apple green, 20%, utilities, green, 25%, entertainment, the pink one, 10%, and the last one, savings, 5%. So a pie chart shows how the part of something relate to the whole. It is divided into sectors where each sector represents a particular category. So the entire circle is one whole or equivalent to 100%. And a sector of the circle is a part. As you can see in the pie chart, so here, a slice of pie for clothing has been separated from the rest of the chart. Next one, bar graph. A bar graph is a graph which uses horizontal or vertical bars to represent data. When a bar graph has bars which extend from left to right, it is called a horizontal bar graph. On the other hand, if the bar extends from bottom to top, it is called a vertical bar graph. So a bar graph is used to compare data. Example, here is an example of a bar graph. Next one, the length of a bar represents a quantity. So the bar, which are representations of the quantities, can easily be compared by examining the lengths of the bar. Example, we have a survey of students' favorite after-school activities was conducted at a school. So the table below shows the result of this survey. So here is the table, activity, and the number of students. In playing sports, we have 39 students. Do household chores, 56. Earn money, 44. Chat online, 55. Watch TV, 26. So in bar graph form, here is in the bar graph. Watch TV, we have 26. Chat online, 55. Earn money, we have 44. Doing household chores, 56. And then playing sports, we have 44. So the highest of them is doing household, followed by chatting online. And then the least one is the watching TV. Note that each quantity listed in this table corresponds to a particular category. Accordingly, the data from the table above has been displayed in the bar graph below. So moreover, the data in this table is not changing over time. So a line graph would not be a good way to visually display this data. Next one, line graph. A line graph is used to show changes in data over a period of time. Data like changes in temperatures, income, and population can be represented by a line graph. For example, here is an example of line graph. The relation between these data is graphed on a rectangular coordinate plane. The quantity time is usually plotted along the horizontal axis, while the other quantity is plotted along the vertical axis. Points are plotted based on the relationship of quantities, and those points are connected by a line. So that's why it is called a line graph. Example, we have the table below shows daily temperatures for Baguio City recorded for 6 days in degrees Celsius. So here is the table, temperature in Baguio from day 1 to 6. So day 1 we have 18 degrees Celsius, day 2 16 degrees Celsius, day 3 16 degrees Celsius, 4 15 degrees Celsius, 5 we have 13 degrees Celsius, and 6 we have 12 degrees Celsius. So we have the line graph for the table temperature in Baguio City as per day and temperature. So here is the example of the line graph. So the data from the table here shows that the temperature change from day to day has been summarized in a line graph. This line graph shows a change in data over time. So a line graph is useful for displaying data or information that changes continuously over time. So let's compare the graphs of the three presentation of data. So what type of graph to be used given a set of data? So we have number 1, we can use a pie chart. A pie chart is used to compare the parts of a whole. It represents the data visually in the same proportion as the numerical data in the table. The area of the sector in a pie chart is in the same proportion to the whole circle as each item is the total value in the table. Next one, the bar graph. When do we use the bar graph? Bar graph is used to compare facts. The bar provides a visual display for comparing quantities in different categories or groups, or a bar graph helps us to see relationship quickly. And then last one, the line graph. When do we use the line graph? It is used to display the data that changes continuously over a period of time. So it allows to see overall trends such as an increase or decrease in data over time. Here, example number 1. Let us identify what type of graph can be used given the following set of data below. So problem number 1. The table below shows the number of mobile phones sold by a brand for this month. What graph would best demonstrate the sales of each brand? So we have the cell phone sold this month, we have the brand, and then brand number sold. Samsung, we have 25. Huawei, we have 15. Oppo, 32. LG, 18. And then Cherry Mobile, we have 10. So what type of graph is best for this set of data? So we have here the bar graph. Why? The numerical data in this table is not changing over time. So a line graph would not be appropriate for summarizing the given data. The bar graph stresses the individual sales of each brand as compared to the others. So the bar graph does not use the total of all items in the table. So this makes sense that the bar graph a more direct and accurate way of representing the data in the said table. So problem number 1, bar graph is the answer. Next problem. Problem number 2. So what graph is appropriate for this set of data? The table below shows the humidity level recorded in Alcala for 7 days. What graph would best demonstrate the humidity level for each day? So from day 1 to 7, we have the day humidity level. We have day 1, 40%, 2, 45%, 3, 50%, 4, 44, 5, 43, 6, 51, and 7, 39. So the humidity level is given as a percent. So at first glance, this might lead one to think that a pie chart should be used to summarize this data. However, the data in the table does not indicate any parts in relation to a whole. Thus, a pie chart is not the right choice. The data in the table is changing over time. So, a line graph would be the appropriate choice for summarizing the given data. So the answer is a line graph. Next one. Third example. The table below shows the composition of Earth's atmosphere. What graph would best represent the composition of the Earth's atmosphere? So we have the composition of Earth's atmosphere. We have gas and then gas percent. Nitrogen, 77, oxygen, 21, and other gases, we have 2. So, the word composition indicates that we are looking at the parts of a whole. So, the Earth's atmosphere is the whole, which is 100%, and each gas is a part of that whole. Accordingly, a pie chart is the best choice for summarizing this data. Next example. So let's move on to the graph of frequency distributions. So we have two graph for frequency distributions. So when a data set has many entries, it can be difficult to see patterns. So in this section, you will learn how to use frequency distributions to construct graphs. So histogram. A histogram is a bar graph that represents the frequency distribution of a data set. Its y-axis shows the number of the data values within each class of a frequency distribution, and x-axis shows the class boundary of each class. A histogram consists of tabular frequencies shown as adjacent rectangles erected over intervals. The height of a rectangle is also equal to the frequency. There are no gaps between the bars. So example, draw the histogram of the following frequency distribution. So here are the scores, class boundaries, and then frequencies. So So we have scores from 1 to 10 to 51 to 56. And then class boundaries, we have the lower limit and then the upper limit. And then we have the frequencies for each class boundaries and for each scores. So let's graph. So here is the histogram for the given table. So we have the frequencies 0 to 18, and then histogram we have the x-axis, the the scores or the lower limits. Because consecutive bars of a histogram must touch, or bars must begin and end at class boundaries instead of class limits. So class boundaries are the numbers that separate classes without forming gaps between them. That's why the graph for histogram is like a bar, but they have no gaps in between. Next one, we have the second ogive. So an ogive is a line graph of the cumulative frequency distribution. So there are two ways or two types of ogive. So we have the less than ogive. So in graphing the less than ogive, the cumulative frequencies are plotted against the upper boundaries. And then for the greater than ogive, in graphing the greater than ogive, the cumulative frequencies are plotted against the lower boundaries. So for example, draw the ogive of the following distribution. So we have the scores from the histogram of the example from the histogram, and then added by the less than cumulative frequency and then greater than cumulative frequency. So in finding the less than cumulative frequency, we start from the lowest score and then we add the frequencies up until we get the total number. And then for greater than cumulative frequency, we start with the upper or class boundaries 16 and then added, let's add 16 plus 5, which is 21, then 21 plus 2, 23, 23 plus 8, we have 31, 31 plus 14, we have 45, and 45 plus 8, we have 53. So let's graph. So the graph for the less than ogive, we have here 0 to 60 and then from 10.5 to 60.5. And then for greater than ogive, we have 0 to 60 and then 0.5 to 50.5. So less than ogive, the graph or the line graph is here, continuously up. And then for greater than ogive, to the left. So that's all for today. Thank you for listening and see you on the next video lesson.